Assignment is a technique where we assign workers to the jobs, salesmen to the territory, or machines to the jobs, or particular workers to particular machines. In short, we have certain resources which can perform certain tasks. Those resources could be salesmen, those resources could be machines. So we have certain resources which can perform certain tasks. Now we need to find out best possible assignment combination which will minimize our total cost of assigning those workers to those tasks. So the method that we are studying here is Hungarian method. This is the most frequently used method for assignment. Like we have methods like WHAM, Northwest Corner method, least cost method for transportation. So here we have Hungarian method for assignment. Now first let us see how assignment problem is organized. How do we represent an assignment problem? For the example, let us say we take 4 workers and 4 jobs. Okay, so here we go with our 4 workers and 4 jobs. Let us say that my workers are written on this side. Workers, jobs. So I have 4 workers. Let me call them A, B, C, and D. Then I have certain jobs, maybe P, Q, R, and S. So I need my workers to finish these jobs. Now, not every worker has same capacity, same capability to perform all the jobs. Maybe when I assign worker A to job P, he takes 8 minutes to complete it, while he takes only 2 minutes to complete this task Q. Maybe he takes 9 minutes to finish R and only 3 minutes to finish S. So what do we have here? We have a situation where A can perform all these tasks, but it takes different amounts of times, 8 minutes, 2 minutes, 9 minutes, and 3 minutes respectively to finish P, Q, R, and S. Then, let us say similarly B takes time 5 minutes, 4 minutes, 3 minutes, and 8 minutes to finish P, Q, R, and S. Then let us say C takes 9, 7, 8, and 4 minutes. Then D maybe takes 6, 8, 9, 8 minutes to finish these tasks. Now, we have 4 workers working for me, A, B, C, D. Then I have 4 jobs that I want these workers to be finishing for me. I want that all these tasks PQRS should be completed by these workers for me. In order to solve these problems, first we need to do a row reduction. What is row reduction? Row reduction is a step, let us say, wherein I'll be reducing every row in a way that it will have at least one zero. So first step that we take is row reduction. How do we go about it? We'll make make a new table of let us say same size, maybe here. Who were our workers? They were called A, B, C, D, A, B, C, and D. What were my tasks? P, Q, R, and S. And timings that A needed were 8, 2, 9 and 3. So what is the least time that he takes? Least time that he takes is 2 minutes. So in row reduction, what I'll do is A is my first row and 2 is the least time. I will subtract 2 from all these values, 8, 2, 9, 3. So what do I get when I subtract 2 from all these values? I will get a 6, 0, 7, 1. 8 minus 2 will give me a 6, 2 minus 2 will give me a 0, 9 minus 2 will give me a 7 and 3 minus 2 will give me a 1. So I have subtracted 2 from all these costs or times, rather times. So what do I get? I get 8 minus 2, 6, 2 minus 2, 0, 9 minus 2, 7, 3 minus 2, 1. This is row reduction for our first worker or first row. Now let us proceed to row reduction of second row. What do we have? We have minimum as 3. So this 3 will be subtracted from all values. 5 minus 3, 4 minus 3, 3 minus 3 and 8 minus 3. So let us go ahead and subtract this 3 from all. 5 minus 3 giving me a 2. 4 minus 3 giving me a 1. 3 minus 3 is 0. 8 minus 3 is 5. So this is row reduction for my second row. Now let us proceed with third row. Row reduction of third row. What is the smallest this time? It is 4. So I'll be subtracting 4 from all these. 9 minus 4, 7 minus 4, 8 minus 4, 4 minus 4. I have to subtract the smallest value in each row from all other cells. And this time I'll be getting 9 minus 4 is 5, 7 minus 4 is 3, 8 minus 4 is 4, 4 minus 4 is 0. Now can we proceed with last one? That is D. Minimum is 6. Let us subtract 6 from all. 6 minus 6 would give me a 0. Then I have an 8. 8 minus 6 would give me a 2. 9 minus 6 would give me a 3. And last again I have an 8. So 8 minus 6 would give me a 2. Now, here we have a row reduced matrix. This is row reduced. Row reduced means each row has at least one 0. This row has this 0. B row has another 0. C row has another one. D row has another one. So every row now has at least one 0. There can be more zeros, but definitely there will be at least one 0 in each row after row reduction. Now what we need to do is proceed to our second step, which is column reduction. What is column reduction? Column reduction is same procedure with our columns. Column reduction. What is column reduction? We'll follow the same procedure. This time what we did was we subtracted minimum in each row from all respective rows. Now what we'll do is we'll subtract minimum in each column from all elements of respective columns. So let us go ahead and create a new matrix. We have a 4 by 4 matrix, and then we have our, let's say, workers A, B, C, D. We have our jobs P, Q, R, S. Now, what is the minimum in first row? First column rather, 6250. 0 is the minimum. So I'll subtract the 0 from each of the elements. What happens when you subtract 0 from each of the elements? Practically we end up with same values. So 6 minus 0 would be a 6, 2 minus 0 would be a 2, 5 minus 0 would be a 5, 0 minus 0 would be a 0. So ultimately there is no change. What happens with column Q? We have 0 as minimum. So once again, all the values will remain unchanged, because 0 minus 0 would give me a 0, 1 minus 0 is 1, 3 minus 0 is 3, and similarly we have a 2. If we have a look at column R, once again we have 0 as the minimum. So if you subtract this 0 from complete column, what do we get? 7 minus 0, 0 minus 0, 4 minus 0 is 4, again a 3. And same happens with this last column. What do I get? 1, then there is a 5, 0 and 2. So in this case, it was a chance that all the values remain unchanged. Because if you understand the problem, what we were doing was in column reduction was that we were subtracting the minimum of each column from all other values. Now incidentally, minimum in each column happened to be 0. So it did not change our values exactly. For column reduction, I have a matrix wherein each row has at least 1 0. Fine. And even each column has at least 1 0. Here we can see. So this is what row reduction and column reduction will do to your matrix. That each row and each column will have at least 1 0. They could have more zeros, but they will definitely have at least 1 0. Now let us go ahead and make the assignments. How do we make these assignments? Let us prepare this table once again for us. Now, we proceed to our next stage of assignment. For assignment, you need to take care, strictly adhere to these priorities that we have. While making assignment, this is a priority list. What are my priorities? They go in this order. First priority. Who gets first priority? A unique 0. What is a unique 0? A unique 0 is one who is alone in its row and column. Alone in its row and column. If we have such kind of 0, then it is called a unique 0. Second priority is, if you don't find a unique 0, look for single 0. Who is a single 0? Who is alone in its row or column. Now, if you look at these conditions, they may look similar, alone in its row and column, alone in its row or column, but this is the catch. Unique is one who is alone in its row and in its column, while single is someone who is alone in its row or column. It is not necessary to be alone in both row and column. It can be alone in either of those. So these are the two priorities. Then we have a third scenario which generally we come across because it is very hard, very hard to find unique zeros. Yes, single zeros you may find here and there, but generally what we see is there are a lot of zeros. More than 1 zeros in a row, more than 1 0 in a column. So in such case, what we do is we search for a row or column with minimum zeros. You have to search for a row or column with minimum zeros in it. Then only can we make those assignments. When we get minimum rows and minimum zeros in row and column. So first let us see What do we mean by unique zeros? Now, how do we find out unique zeros, single zeros, or rows and columns with minimum zeros? First in this priority list is unique zero. Let us go ahead and find unique zeros. Let me scan. Who is the first zero? This is the first zero. Is it unique? What do I mean by unique? Alone in its row and column. Is it alone in its row? Yes, it is alone in its row because this is the only zero in its row. Is it alone in its column? Yes, it is alone in its column. This is the only zero in its column. 0, 1, 3, 2. So yes, definitely this zero is a unique zero. And I can definitely go ahead and assign it. This is my assignment. Now, because A could perform only one task and that task has been allotted as Q. So A will not perform any task further. So I remove it from my calculations. Let us use some other color. A will not work anymore. And what about Q? Even Q has been performed. Task Q has been performed by worker A. So now neither worker A nor job Q will be entering in my matrix. Now, who is another one? We see here is a zero. Is it alone in its row? Yes, looks like this zero is alone in its row. 2, 1, and 5. Is it alone in its column? Yes, looks like 7, 4, and 3, and 0. So definitely it is a unique zero, and I can go ahead and make an assignment in this zero. Let us make an assignment. Now, once we have made this assignment, let us remove its row and remove its column. Now, if you have a close look, A and B cannot participate further because they have been allotted a task. Q and R will not participate further in my solution because they have already been performed. Now, where is our next zero? Here it is. Is it a unique zero? Let us check. In its row, yes, it is alone. In its column, yes, it is alone. So definitely even this one is a unique zero. What do? We go ahead and assign it. And as soon as you assign it, you need to remove its row, remove its column. Now, where do we go? We have a zero. Still a zero is available. And is it unique? Yes, it looks like being unique. Let us go ahead and assign it. Now, do we see any zeros? No. All zeros are exhausted. All zeros have been assigned. Now, I had 4 workers to start with. Have I assigned all these workers to all the tasks? Let us check. A is doing a task. Definitely B has been assigned to a task. C is assigned to a task. D is assigned to a task. Every worker is assigned to some task. What about tasks? P, someone is there to do this task. Q, someone is there. R, okay, someone is doing this task. S, someone is doing this task. So all my workers have been assigned to tasks and all my tasks are being performed. So this completes my first assignment example where all workers have been assigned to tasks. What are the combinations? A is going to Q, B is going to R, C is going to S, and D is going to P. Now, to find the final solution, let us jump to the first matrix. Where is A going? A is going to Q. A to Q. And then we have B to R and C to S. A is going to Q, B is going to R, C is working on S, while D will be working on P. So we have our 4 assignments. What have we done? We have assigned A to Q, and it is consuming 2 minutes. B to R, it is taking 3 minutes. C to S, it is taking 4 minutes. And D to P, it is taking 6 minutes. So I can complete all these tasks in 15 minutes. These 15 minutes are minimum possible time that these 4 workers will take in total to finish these 4 tasks. So this is our very basic, very easy, very simple, elementary assignment problem using Hungarian method.